Hello students, today we are going to learn a new topic in electronics, but a very important topic, and that is about operational amplifiers, which we call in short as op-amps. Now we shall understand how it came into being. It was in around 1960s that when integrated circuits came into being, or when it was invented, this operational amplifiers become so popular. And the invention of op-amps or operational amplifiers, it was a great leap in the era of analog electronics especially. And an operational amplifier, it is part of many electronic devices, whether it is timers or oscillators, comparators. Most of the electronic devices, op-amps are part of it. And the major importance of these amplifiers is that operational amplifiers is that it does many arithmetical operations like addition, subtraction, integration, which you do in mathematics. Okay, then you have differentiation. So all these can be performed mathematically using these operational amplifier devices, op-amps. So this is the great advantage of these op-amps, and this is why we call them as operational amplifiers, because they do all these kinds of operations, and that is the reason why we call these amplifiers as operational amplifiers. Okay, so now I will come into why they are basically amplifying devices. Then first I'll show you, this is basically the symbol of an op-amp, which means that there are these are two input terminals, and you have a single output. So that is the peculiar feature of an op-amp, that is you have two inputs. So I give input signal at these two terminals, then you will get an output, a single output. Okay, and we call one of the input as an inverting input terminal and the other as a non-inverting input terminal. Okay, and the reason is that if you give an input signal at that inverting terminal, not giving anything in the non-inverting, we'll get an output which is opposite in phase as that of the inverting, or that of the phase opposite phase as that of the input at the inverting terminal. And if you give an input at the non-inverting terminal, you will get the output which is in same phase as that of the input. So we'll have a more closer discussion about these things later, but I would just want to tell you that there are two inputs. Out of that, one is called inverting input terminal and the other one is called non-inverting input terminal. And there are two supply voltages. You know that any transistor or any amplifier to work, it requires some supply voltages. Here we normally connect two supply voltages, that is positive voltage at one terminal and the negative voltage at another terminal. And it is not important that every op-amp has this peculiar feature of giving two supply voltages. Sometimes some of them have only one supply voltage. But anyway, so that depends upon the operation which you want to perform, or depends upon the op-amp with which you are working. Okay, but anyway, it has two polarities, and the basic importance of this polarity, it requires bias voltages. Transistors and all requires bias, or any amplifier requires bias voltages and all for working, right? So, and now it will also, if you give only this positive and negative voltages, the output will actually have variation on either side of the 0 volt. Okay, so with that importance, you have to give the supply voltages. Okay. Now this is all about a general description of an op-amp. This is the symbol of an op-amp. Op-amp has basically two terminals as inputs. Then you have two terminals where you give supply voltages. Then you have an output terminal. But doesn't mean that it has only this much terminals. it has more than that. Basically, an op-amp will have more than this. But then these are the important terminals which is very important for an op-amp to work. That is two input leads, then two supply voltage terminals, then you have a single output terminal. Now, when you say that op-amps, basically you know that there are basic amplifying devices are transistors, right? Or you have the FETs or something similar to that, MOSFETs or anything like that. So there should be in an amplifier, basically there should be some kind of a device or some kind of an electronic device which actually performs the amplification. Okay, so that is where we come to understand more about it. I have shown here a very complex circuit diagram which you may find very difficult to understand. But then you can see that there are a number of transistors arranged or cascaded one after the other or in series and parallel and all, right? So basically an op-amp contains, and you can see here there are two leads given, right? So one is there is a to the base of one transistor you take the output, or it is actually the input, and the input, one of the input is given to the one base of a transistor or the base of a transistor, and another input is given to the base of another transistor. So actually what you are seeing in an op-amp equivalent symbol, or in the symbol of an op-amp, you saw two input leads, right? And basically these are the two input leads. Okay, so you can say that this is one lead. Okay, and let me take this lead out. Okay, this is another lead, and you called one as the inverting input, right? This is the inverting input and this as the non-inverting input, right? So you can see that this is actually, this two input leads is basically is being gone to the base of two transistors, right? So one to n, or one input to one base of one transistor and another input to the base of another transistor, and all the other things which are within that. Okay, that is after that, of the input leads, you can see that there are many transistors, resistors, capacitors in between. They are all packed in a single unit, and finally what is out of the op-amp is the output here, right? So this is the one thing which you have seen as the output. Then there are supply voltages, right? So here you can see that there is a lead which is given to one positive supply, and there is another lead given to the negative supply. So basically when you always talk about op-amps, you are always bothered about only this input terminal, output input terminals, then this output terminals, this supply voltages, etc. All the other things which are actually within that does the action of this amplification. So that means when I give input signals at these terminals, with the action of all these transistors and other components, the amplification part is actually done, and what you get at the output of an op-amp is what you see from the output 6. Okay, so everything, all these things together, they are packed within a packed circuit, and that is what we call as an integrated circuit. So an integrated circuit basically contains all the transistors, resistors, capacitors, and all the electronic components packed together in a very small size, in a very short package, and it is compacted together. And such a thing is what we call as an IC, right? And you can see that IC is what I have shown here. Basically the whole thing which you see here, that is being packed into or integrated into a small package, and that is what you see here. And the leads which you say, one, this inverting, non-inverting, that supply voltages, then output, and that is what you see as the terminals of these ICs. Okay, what you see out are the terminals which you give as inputs and which you take as output, then supply voltages, and everything transistors, capacitors, resistors all together packed in a single unit is what is actually seen here. Okay, so this is what we can understand from this is normally op amps or no op amps are basically seen in the form of an IC, and we normally doesn't bother about what is happening inside, but you only know that when you give input to the input terminals, depending upon the input you will get an output. So at the terminals you have to give the inputs, or one of the two terminals you have to give the supply voltages, and from one of the terminal you have to get the output. So all of them are actually strictly fixed for a particular type of op amp. So for a particular op amp, you will be giving inputs at one particular terminal and numbered. You know, when you give a transistor, this is 1, 2, 3, 4. You can actually number the terminals. So it is fixed that one is particular sorry, one of the terminal which is numbered say 2, that is for a particular non-inverting terminal, or 3, it is for a particular input terminal, and that's 6, and that terminal is actually fixed to take output. So that is always fixed in the case of an op amp. Now shown here is also another form of this thing, that is actually what is taking place inside. There are different stages within the package which you see here, or the whole thing together we can be classified into different stages. One is the input stage, and another is intermediate stage. Then you have a level shifter, then you have the output stage. So that all depends upon how you want to cascade it from one stage to another, and finally how it has to be amplified, and that all things you need not have to bother much. But I said generally for an understanding, that is this different sets of transistors which you give, they perform different tasks within that. Okay, so that is all about the internal circuitry in a op amp. Just to make you understand what these basically, they are not some blind device, they are actually devices, or op amps are basically some device which contains many transistors which actually does the action of amplification. Okay, so this is all about the internal circuitry and the op amp, introduction to op amp. Now we are going more into the details of an op amp. As you have seen here, um, you can see here I have the two leads, inverting and non-inverting, and let me call this inverting terminal voltage V1, and the input at this non-inverting as V1, and the input at the inverting, let me the V2, and let me call this as V1, inverting as the V1. And you know that you give input. Basically what we do is you normally give an input in between this V2 and V1. So let me call this as an input which is given between these two terminals. And actually output is difference of this V1 and V2 amplified form. That is, I can say that output, you know that this op amp will have a gain, and let me call this gain as AB. As in the case of a transistor, this op amp is also basically an amplifying device. That means it should have a gain, right? So let me call this gain as A, and you know that, let me call this as output. Okay, so that means you will get an output which is actually gain multiplied by the input. Here, the input is not a particular value V1 or V2, but instead of that, input is actually the difference between V1 and V2. Okay, so input is actually V2 minus V1. So it is constructed in such a way that the output voltage is actually A times V2 minus V1, or I can say that the difference of the signal given at the input is amplified at the output. So which means that it is called as a differential amplifier, and that is the reason why you call this op amp as a differential amplifier. When you learn about op amp, or when you look for op amp, one of the important parameter or feature which is discussed about op amps are they are differential amplifiers. And why do we call they are differential amplifiers? Because the difference of the input signals amplified out, or it is the output voltage is the amplified form of the difference of the input signal, and that is why we call it as a differential amplifier. Now, depending upon the signal, you know that if suppose, let me call that, and we said that suppose if I don't give any signal at the input V1, or which means that I can make V1 grounded. Okay, I give V1 grounded, that is something like this, it will come. This is V1, I keep V1 grounded. Okay, and then here you're giving supply voltage. Now what it is actually done is that when you give like this, you give input only at the terminal V2. Now you look at the output voltage. So first case, which means that V1 is equal to 0. Now you see what is output voltage VO. When V1 is 0, you have only V2. So I'll get output as A times V2. So that means when you give input at the non-inverting terminal, but nothing at the inverting terminal, okay, or when you give a signal at the non-inverting terminal, I can say that the output will be of the same polarity. So whatever is V2, that you will get as the output. So which means that when if my signal is like this, okay, I'll get the output also amplified, but in the same phase as that of the input. But now the second case, let me take, that is I keep V2 0, don't give any input signal there, but then, so then I mean that I'm grounding. So V2, not giving anything here. Instead, I give a supply voltage at V1. Okay, I give a voltage at V1. So that means that according to the output, we know output voltage VO is equal to 8 times V2 minus V1. 8 times V2 minus V1, and you know that V2 is 0 here. So that means you will get minus of 8 times V1, which means that you get the output which is in opposite phase as that of the input. So when I give an input here, there is no input here. Instead, if you are giving an input here, okay, what you get at the output is basically amplified signal but out of phase with that of the input. So that is why we call this as inverting and non-inverting terminal. So it is actually given within the op-amp in such a way that if you give an input at the non-inverting terminal, you will get the output with the same phase as that of the input, okay, which will not invert the input. But then if you give an input at the inverting terminal, the output voltage will be inverted when compared to that of the input signal. So that is how it acts as a non-inverting and inverting amplifier. But then suppose if I give input between V1 and V2, or if I give input at V1 and V2, okay, sorry, if I give an input at V1, I give an input, if I give an input at V2, similarly I give another input at V1 also, then basically what it does is A is the difference between the V2 minus V1. That is, if you can say that if V2 is high, then the output will be positive, or it will be in the same phase as that of V2. But if V1 is high, you can say that the output will be in opposite phase, or that is depending upon the values of V2 and V1, you will get the output voltage as positive or negative. So polarity of the output voltage will change depending upon the value of V2 or V1. So this is how basically an operational amplifier works, and we basically mean this to amplify the difference of the voltages at the V1 and V2. And depending upon in the mode of operation, that is, it can be either connected in a non-inverting mode, giving signal only at the non-inverting terminal and keeping inverting terminal grounded, or we can use that in the inverting mode, giving signal only at the inverting terminal. Or you can either use that in the differential mode. That means you give signals at the V2 as well as the V1. Okay, in whatever be the case, we can say that, so depending upon the mode, the amplification will be done. Okay, so this is all about the introduction on operational amplifiers. So in the next sessions, we'll talk more about it. So thank you very much.